All right, in this video, we are going to talk about the next generation science standards. So these are the standards that are used in Lewiston and in Idaho. We are adopting them little by little. So these are the next generation science standards. A number of states have adopted these standards. Actually, more states are adopting them little by little. So the NGSS standards use a three-dimensional framework. So this framework comprises these three dimensions. So we have scientific and engineering practices. So as teachers, we need to make sure that our students understand these practices, and we will see what these scientific and engineering practices are. Then you focus also on disciplinary core ideas. This is the content that you want your students to learn. So in terms of science, we have physical sciences, life sciences, earth sciences, engineering, technological practices. Then we have cross-cutting ideas. So these ideas are present in all the disciplines. So it's kind of like the content, the knowledge, the practices that are present in all the science disciplines. You are going to find them in physical science, you are going to find them in life sciences, earth sciences, engineering, technology. So when making your lesson plan, you are thinking about all these three dimensions. How have I achieved the three dimensions as proposed by the NGSS? So let us start with the scientific and engineering practices and see what they are. So when we talk about scientific and engineering practices, we are talking about asking questions. Right? If you are making a lesson plan, does it include questions that you want your students um, to ask, or that you want your students to answer? Right? Or is there an engineering problem that you want to define as a class? Now, to answer these questions, are you developing and using models? So that's part of scientific and engineering practices, because to develop a model, it needs some engineering understanding and using the model. So both of these need scientific and engineering understanding. Are you planning and carrying out investigation? So as you can see, this is kind of part of the scientific method that we discussed in class. They need to be able to analyze and interpret data, use mathematics, information and computer technology, and computational thinking. So are they using math in their science? Construct explanations, engage in argument from evidence, obtaining, evaluating, and communicating information. So these are the scientific and engineering practices that we need to include in our lessons. So in terms of asking questions, I have looked at it in terms of the grade. What type of questions should we ask for specific grades? The questions that you are going to ask at K2 are not exactly the same questions as the ones you are going to ask at K3 to 8, because you are thinking about the level of your students. For example, at K2, you ask questions based on observations to find more information about the natural or designed world. So these are just simple observations that the students make. So questions that can be answered by a simple investigation, they should be able to define simple problem. So you are doing things at their level. When you go to K3 to 5, now you introduce variables in their questions. So you introduce variables in their question. What happens if we change this? Right? In K1 and 2, you are just asking a question. You don't worry about changing the variables. When you go to 3 to 5, you are thinking about changing variables. What happens if I change this variable? What happens if I change length? In this case, you are using scientific data versus non-scientific data. You have a question and you are trying to investigate it. You are trying to identify which data is testable, which data is non-testable. So you are doing this at K3 and 5. At this point, students should be able to predict an outcome. So in 3 to 5, when asking questions, maybe before you ask question, ask them to make a prediction. What is going to happen if we do this? Okay, 6 to 8. Now these questions require sufficient and appropriate empirical evidence. When they do their experiment, they need to get enough evidence because now they are growing up. Now their thinking is maturing, is becoming more and more complex. So they need to put in more responsibility in how they handle their questions. The observations at this point are very, very carefully done, more careful. And they should talk more about the evidence. So, in simple terms, what we are saying is at each level, you increase the complexity of the questions that you want your students to learn or to answer. Then we have developing models. So, K2 is just simple models built on prior experiences. Things like they see a tree, can you draw a tree? They see a car, can you draw a car? So this is simple models of things that they see, replicas. Or they can dramatize something, make a story. But in this case, what is important at K2 is that you are representing concrete evidence, things they can see. Right? So you are representing things they can see or have seen, because we know these are young kids who are not yet abstract. At K3 to 5, you are still doing these simple models, but here you are talking about events. It's not just a car, right? Can you represent something, an event that had occurred? Can you draw a model? For example, lightning. Can you draw a model of lightning strike that occurred somewhere? So this is a little bit more complex. Can you design a solution to this problem? We have a pothole problem on the road there. Can you draw a model that designs a solution to that? So you are events that they have seen, right? So they have events they have seen, and you want them to describe those events using model. In this case, we are talking about scientific events, and they design solutions to deal with some of those events. but still, these are things that they can see. Now, when you go to 6 and 8, yeah, we are developing models, using models, revising models, but now we are we are dealing with things that are more abstract. I mean, in this case, like you can talk about an atom. An atom is something that is more abstract. You can ask them to draw a model of gas particles. We usually don't see gas. We usually don't see gas particles, but these are kind of abstract terms to us. At this point, your students should be able to draw things like those in K6 to 8. So that is a scientific practice developing, or scientific and engineering practice that is dealing with developing models. What about design systems? Can you design something that will show you how gas particles work? Things like a syringe, right? So at K2, what you want to do with this part, I'm just giving you some examples of what you do in developing models. And it depends on the level. You see, from K2 to K6, the complexity uh, increases. So for K2, we distinguish between a model and the actual object. So it's something that they see, they have drawn, give them a chance. What is different between the model you have drawn or the model you have constructed and the actual object? Compare your model to a colleague, to a colleague's model, and see if there are some common features and some differences. Right? Develop a simple model based on evidence to represent a proposed object or two. Now, when you go to K3, 5, it becomes more complex. You want your students to be able to identify limitations of models. Now, here, you can develop a model using an analogy. As you can see here, you are getting more and more abstract. An analogy, an example, or abstract representation to describe scientific principle or design solution. Um, because you are dealing with abstract, you can develop a diagram or a simple physical prototype. So grade 3 to 5, you need to give your students a chance to propose something from their head, and then they draw a prototype of that. So that is an engineering practice. What it means is, when making your lesson plans, you need to include those activities uh, that will ask your students to propose something new in their head and then draw that. That is kind of engineering practice that is being encouraged by the NGSS. Now, when you go to K6 to 8, it's not just mentioning the limitations of models. You have to evaluate them, talk about them, discuss them. So this limitation, is it a good limitation? What should we do? Should we mitigate it, or should we just leave it and say it's a limitation, it's not going to affect our model? If it is going to affect our model, what changes should we make to the model so that we are able to deal with the effects of these limitations? So this is different from here, because in grade K and 3, you just identify them. You don't discuss anything about them. In grade 6 and 8, you have to discuss the limitations. and see how you are going to minimize the effect of that limitation on your model. For example, you are drawing an atom, or you are drawing particles to show atoms, but we know in actual sense the atoms are in constant random motion. Your model is not showing the motion. So what should you do to minimize the limitation, at least to give your model some kind of motion, right? So if I draw atoms like this is not showing any motion. And then I'll say, how do I minimize the limitations of that? Then maybe I should draw the arrows. The arrows will indicate that there's some motion in my atoms. So that one you do at grade 6 to 8. Really, because you are getting more abstract, you draw models of simple systems with uncertain and less predictable factors. Actually, you at this point you want your students to use models to generate data, test ideas about phenomena in natural design systems, right? So you are getting more and more complex. In simple terms, is that as you are developing your lesson, you want to make sure that you are using more, you want your students to develop these models. Then another scientific engineering practice is carrying out or planning and carrying out investigation. So based on the NGSS, when you are planning your lesson, you want your students to answer a question. They answer a question through planning and carrying out investigation. So you just need to make sure that your lesson, you just need to make sure that your lesson asks students to carry out an investigation, because from that investigation, that's how they come up with explanation about a natural phenomenon or natural occurrence. And from K2 to K8, the complexity of this um, increases. But in all cases, you see that we are focusing on collaboration. So you want to carry out these in groups. So K2, the NGSS encourage collaboration. It does not talk about individual experiment or individual investigation. It talks about investigation collaboratively. K3 to 5 is also the same. Investigation collaboratively. So in K2, it's just you're producing data to serve as basis for evidence to answer a question. Here you don't for K2 you don't need to worry about variables, right? Don't need to worry about variables. So just do a simple experiment. You don't need to worry about what happens when I increase temperature. What happens when I increase length? What happens when I change this? You don't need to worry about that. But it is a collaborative activity. K3 and 4, it is also a collaborative activity. But now you need to think about which variables am I controlling, and which variables are changing. So at this point, when you are designing an experiment, worry about variables. So the questions the questions will be different. Yeah. Here, 3 to 5, you can say what is the effect of temperature. So you can say what is the effect of temperature on something, because temperature will be a variable. You'll be changing temperature. Here, you can just say, does it heat up when we apply heat? Things like that. You don't need to worry about how much heat am I applying, but what you worry about, if I apply heat here, does this heat up? That's all. So for 6 to 8, you want your students to plan investigation individually, because now they are more complex. So give them time to plan investigation individually and also collaboratively. So they need to do both. You are giving them more independence than from K1 to K5. So they should be able to identify which one are independent variables, which are dependent variables, and which are controlled variables. And really, it's different from grade 3 to 5, because grade 3 to 5, more, the focus more is on controlled versus the dependent and independent. While grades 6 to 8, the focus is on all the variables. Do we have dependent variables? Do we have independent variables? So you are focusing on all the variables. Do we have controlled variables? So let me just get rid of all the ink. So, and at this point, the students should also think about the tools. What tools are we going to use? So they are more independent. The activity itself is more complex than just, oh, these are the materials, carry out an experiment. In grade 6 to 8, the students can design the materials themselves, or can select the materials they are going to use on their own without being told these are the materials that you want to deal with. And the if you give them, you can just give them materials on your table and say, this is what you want to do. Select the materials that are going to support the claim you have made before doing the experiment. Because now they are grown ups. Their thinking is more complex than the previous grades. Then we have constructing explanations and designing solutions. So this is an engineering practice, something that we are going also to look at when we talk about making meaning conferences. So in K2, K1 to 2, they just want to use information from observations to construct evidence based on the account. Right? So if I put this on a hot plate and turn the hot plate on, I see that the water is boiling. That's it. After some time, right? So if I put water on a hot plate and heat it for some time, the water boils. That's a simple observation, right? And they can say, yeah, it's boiling because the hot plate is providing heat. Right? So when you go to K3 to 5, you are talking about relationships. right? So I have two hot plates. One hot plate here is a small hot plate with my basin there. Another hot plate is a big hot plate with my basin there. Let me give this basin the same, or this container, the same size. All right. So the same size. So, okay, if I put them together, what happens? So you say, all right, the bigger the hot plate, the faster the boiling, right? So the bigger the hot plate, the faster the boiling time. Now here you're looking at the relationships. That is 3 to 5. This is more complex than just a description of observation that we do in K2. And then they can say, yeah, because the bigger hot plate produces more heat than the smaller hot plate. When you go to K6 to 8, now you are looking at explanation that includes qualitative or quantitative relationship between variables. Right? So if we increase temperature, if temperature increases, then um, amount of microbes also increases. So this is a quantitative. If temperature increases, color of the microbes changes from maybe blue to pink. This is qualitative. So you are able, your students are able to look at the variables and think about them in terms of quantitative, that is numbers, and qualitative, things like appearance, structure, things like those. That is at K6 and 8. So in simple terms, when you are thinking about these explanations, and when you are making your lessons, you are thinking about what level are my students? Are they really there? Are they there to deal with quantitative and qualitative relationships? Or they can just focus on quantitative relationships? Or are they at the level that they can look at these relationships? That is in K3 and 5. Another practice is engaging in argument from evidence. So in K2, your students should be able to identify arguments supported by evidence, right? Using that evidence, they can distinguish between explanations that account for all the gathered evidence and those that do not. Right? So some explanations, for example, why do trees grow? Right? That's a good question. Why do trees grow? One explanation can be Yeah, they have water. Another explanation, they have nutrients. A third explanation, they have air, that is oxygen, and carbon dioxide. A fourth explanation, they have a soul. So the students should be able to look at this and say, no, this is wrong. This does not this does not account for evidence. These three account for evidence. So they should be able to do that at K2. Here, they should be able to do more. They should not just talk about the evidence, but the evidence should be based on the research they have done. They need to be able to distinguish between facts, or to distinguish among facts, reason judgment based on research findings, and speculation and explanation. So, for example, these that we talk about here, they must have water, they must have nutrients, must have air. At this point, they would say, why is water important? What does it do? What about why are nutrients important? What do they do? So they are getting more complex than just mentioning the things. K6 to 8 is even more complex. They need to be able to compare and critique two arguments. So, for example, someone can say, growth is largely due to nutrients. And someone will say, oh, growth is largely due to water. So I'll put two arguments here. Growth is largely due to nutrients. That is the first argument. The second argument, growth is largely due to water. So in grade 6 to 8, your students should be able to defend their positions. All right, let me just get rid of this. So they should be able to defend why is growth only due to water? Why is growth largely due to nutrients? So they need to be able to compare and critique two arguments on the same topic, and in the end come up with a judgment. So that is grade 6 to 8. And another science and engineering practices: obtaining, evaluating, and communicating information. Right. So here what it means is they need to be able to maybe read appropriate text, obtain appropriate material, right? So at K2, your students should be able to read grade appropriate text and or use media, TV, radios, to obtain scientific information that can help them determine patterns, evidence about the natural phenomena. So when they do the activities, give them a chance to read something or to listen to something or to watch a YouTube video which can enhance their understanding of the material. The same thing with K 3 to 5, but now we are just getting more and more complex. And here, they are not just determining patterns, but they are summarizing. Right? They listen to something and you ask them, can you write something in your own words, or can you summarize? And they should also think about what they have listened and how is it supported by evidence. In case 6 to 8, now you can see the term here critically, which means we are getting more and more complex. So what it means in simple terms is that you need to think about grade level when your students are obtaining, evaluating, and communicating information. At grade 2, how do they communicate? At grades 3 to 5, how do they communicate? Grade 6 to 8, what is the complexity in their communication? So that was about scientific and engineering practices. So the second dimension of any GSS is disciplinary core ideas. So what I have done is I just took only the physical science one. So things that you are going to teach in terms of disciplinary core ideas based on the any GSS. The first topic is matter and its interaction. So here you deal with the structure and properties of matter, things like atoms, chemical reactions, nuclear processes, things like what happens in the nucleus of the atom. Then the physical science too, we have motion and stability. Here you talk about forces and interaction, forces and motion, types of interactions, stability and instability in physical systems. Then we have energy, that is PS3, the definition of energy, what energy is, conservation of energy and transfer, relationship between energy and forces, energy in chemical processes. So those are under energy. And the fourth one in physical science is waves and their applications in technology. So here you talk about the wave properties, electromagnetic radiation, and information technologies like a guitar, music. Um, so here we can think about music, instrument, then you can think about phones, they use radio waves. You can think about microwave. So these are part of the NGSS core ideas. The last part deals with cross-cutting ideas. So these cross-cutting ideas are present in all the disciplines or in all the science disciplines. Patterns. So we talk about patterns in physical science. We talk about patterns in biology. We talk about patterns in earth science, right? So we can the patterns we can look at in maybe earth science, seasons. The patterns we can look at in chemistry, like periodic table, periodicity. So patterns is are cross-cutting ideas, cause and effect mechanisms, and we talk about causes, of things in biology. We talk about causes of things in chemistry. We talk about causes of things in uh, earth sciences. What are the causes of seasons? What are the effects of different seasons? What are the causes of diseases? That is in biology. What are the effects of specific diseases? So we talk about scale, proportion, quantity in all the sciences that we deal with. We talk about systems and system models. So in physics, we can talk about a vehicle as a system. In biology, we can talk about a tree as a system. And we can draw models of each. We can draw models of trees in biology. We can draw models of cars in physics or in physical science. So systems and system models is a cross-cutting ideas. Energy and matter. So that is we have this one in all the science disciplines. So we can talk about energy in terms of photosynthesis in biology. We can talk about energy in terms of respiration in biology. We can talk about energy in terms of combustion in chemistry. We can talk about energy in terms of force times distance in physics. So energy is a cross-cutting idea. Structure and function. In biology, we can talk about a cell. We can talk about tissues. In chemistry, we can talk about an atom. We can talk about molecules. I mean, we can have structure and function in earth sciences and all the other sciences. Stability and change. We can talk about stability of bacteria, how stable are different types of bacteria when you talk about it in terms of biology. We can talk about how stable are specific atoms when you talk about chemistry. We can talk about stability also in physics. So these are cross-cutting ideas, ideas that you are going to find in each and every um, science discipline that you are going to deal with. So what I'm saying is when you are making your lesson plan, you need to think about all these. You need to think about the three dimension as indicated by the NGSS. It's very important. And I want to see that in your lesson plan. You want to give me that three dimension. Actually, I am going to give you a sample of an NGSS lesson plan. Another thing, NGSS lesson plan does not mean you're moving away from the 5E model. No, it is part of the 5E model. But it just highlights what you are doing in terms of these three dimensions as proposed by the NGSS. Thank you.